have all these waveforms in the report. So it's going to be, I think, very easy, but it's only for you to see how the modulation works.
Sorry, are we able to record the class? Or are you going to record it?
Yeah, I can record these classes. So I'm going to do it, okay?
Okay.
Yeah, let's do it. Okay, maybe few information about the oscilloscope before we start. Yeah, so make it like that. So we are going to use this digital oscilloscope, and as you see, we can observe two signals on two channels. We have channel 1 here and channel 2 here. And to change the, yeah, I can see the example. So let's connect the first. We have also two oscilloscope probes. So let's connect the first one to the sine wave generator. First of all, we need to make the connection to the ground. Okay. Yeah. And now we are able to here. And using these knobs, we can change the y-axis, so we can make the signal bigger or lower. We can also change the scale in x axis here using the third knob. Okay. Oh, yeah. Sometimes the connection is not really that good. Now it's better. Okay. Sorry, but it's no, it's fine. Yes, and so we have these first two knobs for the scale in y-axis and the third for the x-axis. These two knobs at the bottom are for the position of the signal. So sometimes we want to observe two signals at the same time. So to make it visible, we can move one to the top and the other one to the bottom, for example. If we want to measure anything, for example, like in the first step, it's the third task in the instruction list, we need to determine the minimum and maximum frequency and the minimum and maximum amplitude. So we want this oscilloscope to measure these values. So we press here measure. I know that for some of you it may be obvious, but I think one part of this lab is how to use the oscilloscope. So I think some of you may don't know how to do it. So after pressing here measure, we choose the channel that we use. So now it's channel 1. So we press here, and after that we pick the value that we want to be measured. So we don't want period here. We don't need it. We want frequency and amplitude. Okay, and also there is a phase which we don't need. Okay, now we have frequency and amplitude. So you should see it now. Okay. And now we can check what is the minimum and maximum frequency and amplitude of the sine wave generator by using these two knobs. So one is for frequency and the other one is for amplitude. So by rotating these knobs, we can set the proper frequency and also the amplitude. Okay. So let's check what is the range of the frequency. So the minimum frequency is 990 hertz. And the maximum is 10.5, 10.5 kilohertz. Okay. And the same with the amplitude. So the minimal is actually near zero, but here you can see 16 millivolts or 8. The maximum, we need to change the scale. So it's 3 volts. So let's set it to 3 volts and let's say 1 kilohertz. Okay, and now we want to see how the spectrum of the signal looks like in the frequency domain. So to do it, we need to press the FFT button here. So it stands for fast Fourier transform. And here we also need to choose the source. So we choose channel 1. Okay. Let's set it at the top. And we need to adjust the scale so that we can see the spectrum in the frequency domain. And as you see, we have one high peak here. It's here. And we have also two small peaks, which, as you probably know, shouldn't be there because it's the sine wave, so it's probably from the noise. And to measure what is this peak frequency, we need to press the cursor button here. It's over there. And here also we choose the source, which is FFT. Yeah. And by moving this cursor, we can read the value of it here, which is 1 kilohertz, which is as we said at the beginning. Okay, and now maybe we can, yeah, see the our signal in time. And now we can also compare different windows for FFT. So this is the flat top window, which looks very similar. And the rectangular, which looks like that. Okay. And laptop again. Okay, let's go back to our signal in time domain. So now let's measure the carrier signal using the second probe. Here also we need to connect it first to the ground. Okay, the same connection, the common point. Okay. So it's really hard to do it. Okay. And we should be able to see. So maybe let's focus on channel 2 only. Okay. Now we have the signal, and by comparing this to our sine wave, yeah, this is the comparison. So now we know we need to adjust the scale to read the values from it. So we do the same with the carrier generator. So we want to know what is the range of the frequency and the amplitude range. So again, we need to have these two measures. So again, we press measure button. We choose channel 2, and we choose frequency. And we pick also the amplitude. Okay. And now we can see. Oh, it's hard for it to be still. Let's make it this way. Okay. Let's set the same way. Let's check what is the minimum frequency. So the minimum frequency is 10.34 kilohertz. And the maximum it's 620 kilohertz. So let's set it to 500. It can be, let's say it's 470. And the amplitude, so the minimum amplitude is 0 volts. And the maximum is 5 volts, 5.16. So let's set it to...
Sorry, which was the maximum frequency?
The maximum frequency was 620 kilohertz.
Okay.
Like it is now. But we set it to more or less 500. Okay, mouse, it's 500. And we are also going to observe the spectrum in the frequency domain for the carrier generator signal. So we press the FFT here. We pick the source channel 2. Yeah, we can also measure. We can observe the signal in time domain on the top. And we want to determine what is the peak frequency. So by using here, pressing the cursor button, we can read the value of it, which is 550, which is more or less the value as we set for the signal. And also here we can compare the spectrum in frequency domain for different windows. So this is flat top window. Panning window. And rectangular. So let's go back to our signal. Okay, and now we're going to connect sine wave generator to the modulator, and also the carrier generator to the modulator. So using these such cables, we're going to make a connection from sine wave generator to the modulator. Okay. And from carrier generator also to the modulator. Okay. And we're going to observe the signal at the output of the modulator. So let's connect the first oscilloscope probe to the sine wave generator so we can observe the input signal. Okay. We can choose the trigger. And the other oscilloscope probe here to the output of the modulator, which is here. Okay. And now, yeah, maybe this way. And now we can, so the yellow signal is the sine wave, and the blue signal, of course, is the modulating signal. So we can also maybe do it like that. So now the yellow signal is the sine wave, and now we can also compare the modulating signal to the carrier, which looks like that. So you can see that this modulating signal is constructed from these two, exactly these two waveforms. Yeah. And now, by changing the amplitude of
Sorry, I have a question.
Yes.
So the blue one is modulating, right? Modulating signal. Okay.
Yes, exactly. The blue one is the channel 2, and this is the modulating signal. so the modulator signal. And now we can see that by changing the frequency of the sine wave generator, so it's the same frequency of the modulator. And by changing the amplitude of the input signal, we can adjust the modulation. Yeah. So we can adjust here near zero modulation. Yeah. So now it looks very similar to the carrier generator signal. Now it's about 20–30% modulation, percent of modulation. Then we have, by increasing again the amplitude, we have more or less 60–70%. And again, by increasing the amplitude, we can set the modulation to 100%, which is now. And when we further increase the amplitude, we can observe the over-modulating signal now. So you can see here these two, between these two modulating signals, there is over-modulation. Yeah, again, so we have more or less 100% and over-modulation. It's too much. Okay. So now we can, now we're going to, yeah, maybe one more thing. We can also observe the spectrum of the modulating signal. So we don't need channel 1, we need only channel 2. So let's press the FFT button again. And now, I'm not sure if you remember, but we set the carrier frequency to around 500 kilohertz. I think we haven't changed it. So the peak frequency of this modulating signal this is the peak frequency. So the highest peak, sorry, so the highest peak should be the same as the frequency of the carrier, which is 520. So it's more or less the same. And the lower peaks comes from the modulation, as you see. And here also we can compare the spectrum for different windows. So this one is for flat top window. We have also Hanning window. Yeah, these two windows are usually quite similar. And we have also rectangular. Okay. So now let's move on to the demodulation. So now we're going to connect the modulator input to the diode detector input. A diode detector here, maybe not, maybe let's connect it to the demodulator input. And we, first of all, we're going to observe the signal at the output of the demodulator. And after that, we move to diode detector and we're going to observe how it works. So let's connect the first oscilloscope probe again to the input, so to the sine wave generator. Oh, sorry, I confused it. Okay, this is the first one. This is the second oscilloscope probe. It has this thing tape here. So now we connect it to the demodulator output. And now, as you see, we can observe demodulating signal. We can also compare, so the blue signal is the blue waveform is the demodulating signal. We can also compare it to the modulating signal. Okay. No. More or less. Yeah, there is this offset. Yeah, and now, so again, we get input signal and we have the modulating signal. And now maybe let's do it the same, but with diode detector. So instead of connecting the output of the modulator to the demodulator, we are going to connect it to the diode detector input here. And we're going to observe the signal at the output of the diode detector. So again, we have sine wave here and diode detector output. So the blue line is the diode detector output signal. And as you see, it looks very similar to the demodulator output. So it works like that. So it's diode detector is just the simplest type of demodulator. Okay. And last thing from this part, we're going to connect the output of the demodulator, which is either way this demodulator or diode detector, to the input of the audio amplifier, and we're going to observe an amplified signal. Okay. Yeah, you can easily see the increase of the amplitude. So this is our demodulating signal, which is amplified in audio amplifier. Okay. Which has the same frequency as the input frequency also. Okay, we can also do it the same but with a demodulator, but it's going to look very similar. Okay, here. And also we have a demodulating signal, which is amplified in audio amplifier. Okay. So let's move to the second part of the exercise, which is using a microphone. So we have such microphone. So, and I'm going to connect this microphone. I think it's not focused here, yeah? The camera. It's blurred a little bit here. So we can disconnect the whole setup now. And now we're going to connect the microphone to the microphone preamplifier and make the connections like we have in the instruction list. So it's 22 figure. So we're going to connect the microphone preamplifier to the input of the modulator and carrier generator also to the input of the modulator and the output of the modulator to the demodulator and the demodulator to the audio amplifier. So actually we did the same as during the previous exercise, but now we have, instead of like artificial sine wave generator, we have this microphone. So I need to switch it on. Yeah, connected. And we're going to observe, so on channel 1, using this, the first oscilloscope probe, we're going to observe the signal of the microphone preamplifier. And at channel 2, we're going to observe the signal of the audio amplifier. And here, one point here that we usually set the oscilloscope probe to, you can see, to times 10 if we want to observe the amplified signal. So make connection to the ground. Okay, now we just need to set the proper scale, and I'm going to use it as a microphone. And let's check if we can, it's on. Okay, yeah, now I think now we are able to see. Yeah, so now we can observe the signal not amplified, which is the yellow signal, and amplified, which is the blue waveform. So as you can see, we make it work. So we modulated it and demodulated. We can also make the same connection using diode detector. So we can also check if this is going to work. As you know, probably yes. Okay. And now we can also see the signal at these two channels. Okay, so thank you all for today. And I would like to invite you to our next classes, which will be about frequency modulation. Do you have any question considering, I don't know.
I have a question.
Yeah, the lab or the reports. Yeah.
How much time do we have for the reports?
Let's say 2 weeks. Okay. Because
Right.
I told you the other groups it's 2 weeks. I think it's too much, but
and the second question, When will you upload this video from the labs you recorded?
Yeah, I actually I have to think about it because I actually wasn't really planning to do it because you need to attend the classes anyway. But if you wish, I can upload it like today, if you want. If you want to have it like to see it again, okay? Because
I mean, it's
you
just
would.
hard to pay attention to all those values and so on.
Okay.
So, yeah.
Okay, I see. So yeah, let's say it will be also today because I need to make the assignments for you. Yeah, to if you want to put the reports using ePortal because you put them also there. Yeah, not you don't send it to me via email. Okay. Okay, so let's say, yeah, let's say 2 weeks, and let's say it's going to be like by the end of the day. Okay.
Right. Thank you.
Okay, so I'm not sure if you have any more question. You can also, I don't know, write in a chat or send me an email later. If not, then thank you for today and see you next time.